A ball is kicked from point P on level ground. The ball initially travels at 45 degrees to the horizontal. The ball reaches the maximum height after a time of 2 seconds. Air resistance is negligible. What is the displacement of the ball from P when at its maximum height? So first of all, what is the required displacement vector? Displacement, it's a vector which connects the starting and the end points. So it's this vector. This vector is the required vector, let it be S. And we can see that it has two components, horizontal component Sx and vertical component Sy. And you can see that the resultant vector, its displacement, is equal to the sum of two vectors Sx and Sy due to what? A parallelogram rule for the sum of two vectors, and hence the required magnitude can be found as what? Square root of Sx squared plus Sy squared, where Sx is horizontal displacement and Sy is vertical displacement. And we know the general formula for displacement, it's what ut plus at squared over 2. And remember that this formula or this equation, it's a vector equation, and all values should be considered in components or in projection on some axis. So if we consider, and first of all, it is given that there is some initial velocity, let it be u, and hence horizontal component of the initial velocity is what? U cosine of 45. Cosine of 45 is root 2 over 2. Root 2 is 1.7, so it's approximately 0.7 u. And vertical component of the initial velocity, it's u sine of 45. And sine of 45, it's also root 2 over 2, so it's approximately, so it's u sine of 45 and approximately also 0.7 u. And if we consider horizontal displacement, it becomes what? Approximately, or u cosine 45 degrees t, and we consider time to be 2 seconds because it's time to the required maximum height, so it becomes times 2. And notice that acceleration due to gravity, it's vertical, so horizontal component is equal to 0. So for horizontal displacement, it's just uniform motion, or motion with constant speed, and its constant speed, it's horizontal component of the initial velocity, and it's approximately what? 0.7 times 2, 1.4 u. And what about vertical displacement? The same formula, but it becomes u y t plus a y t squared over 2, and the initial vertical component of the initial velocity, it's what? It's u sine of 45 degrees times time, which is also 2 seconds, and we can see the y positive y direction to be up, so vertical component of the initial velocity is positive, and we can see the x to be to the right, so this value is also positive. So, and g is downward, so its component is negative g, so minus 9.8 over 2 and times squared 2 squared. And it becomes what? It becomes, again, it's approximately 0.7 times 2, 1.4 u minus minus what? It's 4 over to 2, 10, it's approximately roughly minus 20, something like that. And you can see that we need the value of u, the initial speed or magnitude of the initial velocity. We know another, so that formula is what? For example, we can consider vertical velocity, Vy, is equal to what? Vertical component of the initial velocity, it's u sine of 45 minus gt. So using this formula, v is u plus at, and in projection on vertical axis or for vertical components, it becomes u sine minus gt. And when it attains the maximum height, it's when t is 2 seconds, vertical component, vertical only, becomes 0. And hence you can see that we can find u. So it's approximately 0.7. u is equal to, it's approximately 20. So u becomes 20 over 0.7. Hence, we can see that the horizontal displacement becomes 1.4 times 20 over 0.7, and you can see it's what, 2, so it's approximately 40. Definitely you may use a calculator, and here it becomes 1.4 times 20 over 0.7 minus 20, so it's 2. 40 minus 40 minus 20, it's 20, and hence it becomes a square root of 40 squared plus 20 squared, and it becomes 10. 4 squared, it's 16. 16 plus 4, which is 10 root of 20. 20, it's what? 4 times 5, and it's 20 root of 5. And root of 5, it's what? 2 point something, 2.4 something. So finally, it's definitely greater than 40. 40, so it's 45. You can see root of 5, it's 2.2, and times 20, so it's approximately 45. It's definitely not 60, it's 45, so C is correct. And notice that question is displacement in general, not just horizontal displacement or vertical displacement. It's just displacement. This vector is required. And that's all for this question.